Now, after calculating this permissible shear stress, we have to go for calculating the torsional moment MT. So this torsional moment MT can be calculated from the power. So P in kilowatt is equal to 2 pi n MT upon 16 to 10 raised to 6. Okay. So in this equation, we have to put the value of power. If you refer the given data, the value of power is 2, value of n is 140 into MT as it is because it is unknown upon 60 into 10 raised to 6. So if you calculate this MT from this equation, you will get the answer. So answer of this MT is 136.41 into 10 raised to 3 Newton mm. Okay. Now this is the answer of torsional moment MT. Now the third point that we have to determine is bending moment. So let us write the heading for calculating the bending moment MB. Now the third point that we have to determine is MB, that is bending moment MB. Okay, we have determined tau. I actually here tau max is directly given. We have determined MT from the power. Now it's turn to find out this MB, that is bending moment. Okay, so this bending moment, to find out bending moment, we have to consider the load, bending load acting on this shaft. Okay, so we will draw a free body diagram for this portion only. So this is a bearing. We will give name this as a point A. The point at which pulley is mounted, it is point B. So this is a point A at which bearing is there, and this is the point B at which we have to mount the pulley. Okay, so here the total downward force, total load acting at point B is self weight of total load acting at point B is self weight of this pulley, it is 300 plus tension in the tight side and tension in the slack side. So we have to write here this tension in tight side here as T1 and tension in tight side slack side as a T2. So we have to add this tension in tight side and tension in slack side here in total load acting at this point B. Okay, so remember that already we have seen this numerical, we have solved this numerical where pulley and belt system is provided. So remember that whenever the belt is provided along with the pulley, so total load acting at this point where the pulley is mounted is equal to self weight of pulley plus tension on tight side plus tension on slack side. So we have to write as total load is equal to self weight of pulley is 300 plus tension on tight side is T1, tension on slack side is T2. So this is the total load at point B. Okay, and this is the point A, that is point at which bearing is mounted, and this distance is given, it is 300 mm. So we will write here. Okay, now what we have to do, we have to just find out the bending moment, and bending moment at this point A will be maximum. Okay, because here there is a bearing, so we can consider this as a portion, as a fix, and we have to treat this as a cantilever beam. Okay, so bending moment at A we have to take as a maximum. So to find out this bending moment, we have to first of all find out the total load, but total load is unknown because T1 and T2 are unknown. So our next task is to find out the T1 and T2. Now in order to find out this bending moment, we must know the total load, but total load is unknown because T1 and T2 is unknown. So now let us calculate T1 and T2. That is tension on tight side and tension in slack side on the belt. And we know that there are two equations to find out this T1 and T2. First equation is MT is equal to T1 minus T2 into a radius of pulley. Okay, so here the value of MT is known, it is 136.41 into 10 raised to 3 is equal to T1 minus T2 into radius of pulley. The diameter of pulley is 180, so radius will be 90. So from this equation we can get the equation T1 minus T2. So first equation that we have got as T1 minus T2 is equal to 1.51 into 10 raised to 3. So this is the first equation to get the T1 and T2. Now the second equation that we required is T1 upon T2 is equal to e raised to mu theta. Here theta is theta star, that indicates this theta star is the angle of lap or angle of contact which is related to pulley and belt. Now put the value of mu. So value of mu is 0.33 into value of this theta star is pi radian. If you calculate this, you will get the ratio as, in order to calculate this ratio, we have to use this scientific calculator. So we have to write as, type as E into bracket 0.33 into pi. So if you calculate this, you will get the ratio as 2.81. Okay, so this ratio of T1 upon T2 is 2.81. So we can write T1 is equal to 2.81 T2. This is the equation number 2. Now if we put the value of T1 here as 2.81 T2 in this equation, we can get the value of T2. So put equation 2 in equation 1, and therefore 2.81 T2 minus T2 is equal to 1.51 into 10 raised to 3. So from this equation we can get the value of T2. So if you calculate this T2, you will get the answer of T2 as 834.25. Okay, so we will write the answer of this T2 as 834.25 Newton. So this value of T2 we have to put in this equation number 2. So put in 2. So we will get the value of T1 as 2344.25 Newton. So this is the value of T1 and T2. Okay, so in order to find out the total load, we have to add this T1 and T2 in this 300, that is the self weight of pulley. Okay, so we'll write here total load as 300 plus T1 is 2344.25 and T2 is 834.25. so total load we can calculate from this. So here, by putting the value of T1 and T2, that is by adding the value of T1 and T2 in this self weight of pulley, we got the total load as 3478.5 Newton. Now by considering this total load, we can find out the bending moment. Okay, now the bending moment at point A is maximum, and we can calculate its bending moment is equal to this total load 3478.5 into this distance is 300. Okay, so we will get the answer of this bending moment as, so we get the answer of bending moment as 1.04 into 10 raised to 6 Newton mm. So this is the value of bending moment mb. Okay, now the most critical part of this numerical is that here in this numerical the belt and pulley system is given. So this is the pulley, this is the belt. So we have to consider the tension in tight side T1, tension in slack side T2, and that we have to add into the self weight of pulley. The self weight of pulley was 300, and the total load at this point B becomes 300 plus T1 plus T2. Then we have calculated this T1 and T2 from this equation. Mt is equal to T1 minus T2 into radius of pulley, and T1 upon T2 is equal to e raised to mu theta star. Okay, and then we have calculated T1, T2, we have added, and we have calculated the bending moment, which is the maximum bending moment. Okay, now we have to put this maximum bending moment MB, MT in this equation number 1. Okay, so now first of all we will put the value of this tau max here as 42 in this equation number 1, which we have written at the initial. So tau max is 42, 16 upon pi d cube under root kb. Value of kb is 1.5 into mb is 1.04 into 10 raised to 6 bracket square plus kt is 2 and mt is 136.41 into 10 raised to 3, and its square. Okay, so from this equation we can get the value of d, that is diameter of shaft. So if you calculate this, you will get the answer of, if you calculate this, you will get the answer of this d as 57.69 mm. Okay, so this is the final answer for this problem, and this answer is nothing but the diameter of shaft. Okay, so this is the solution to this problem.